Good morning, Morgan. Good morning to any of Morgan's friends that might be watching this video too. Today is Python training video 13, and it's an introduction, to functions. Okay, and this is the beginnings of fun. Now, in the last video, you saw how we were using pass statements to return any old value without actually putting any code in a function. But today we're going to actually put something in that function where it'll actually return a result. Okay, so here we go. If you remember the old that while statement that we created way back in the beginning, what we've done is we've taken that statement and we have placed it inside the definition for this function. And of course, the name of this function is going to be FIB for Fibonacci. And then you'll recognize this code. Okay? Now, before we go and run the code, we need to go to the manual, and let's read what the manual says about this so that we can have its opinion on this, not just mine. All right, let's go on over there now. And here we are in the manual. So let's go ahead and let's hear what the manual has to say about these functions.
Defining functions. We can create a function that writes the Fibonacci series to an arbitrary boundary.
All right, so it just introduced that function definition that we just talked about. Now, what they're going to do is they're going to plug the 2000 into the function, and it will return this, and we're going to see that in the program. But let's go ahead and continue with the reading.
The keyword def introduces a function definition. It must be followed by the function name and the parenthesized list of formal parameters. The statements that form the body of the function start at the next line and must be indented. The first statement of the function body can optionally be a string literal. This string literal is the function's documentation string, or docstring. More about docstrings can be found in the section Documentation Strings. There are tools which use docstrings to automatically produce online or printed documentation, or to let the user interactively browse through code. It's good practice to include docstrings in code that you write, so make a habit of it. The execution of a function introduces a new symbol table used for the local variables of the function. More precisely, all variable assignments in a function store the value in the local symbol table, whereas variable references first look in the local symbol table, then in the local symbol tables of enclosing functions, then in the global symbol table, and finally in the table of built-in names.
Okay, I stopped it there for a minute. Remember how I told you earlier about the different layers of the program, how you dig down deeper and deeper and deeper? Well, what we're talking about here is we're talking about these variables that we create. Okay, so what it's talking about is in the lower level you see the local variables, and then you can also access any variables from those functions that we're calling you, but you can't call the variable in the lower function from the higher function. Anyway, with that, let's continue with the reading.
Thus, global variables and variables of enclosing functions cannot be directly assigned a value within a function unless, for global variables, named in a global statement, or, for variables of enclosing functions, named in a non-local statement, although they may be referenced. The actual parameters, arguments, to a function call are introduced in the local symbol table of the called function when it is called. Thus, arguments are passed using call by value, where the value is always an object reference, not the value of the object. 1. When a function calls another function, a new local symbol table is created for that call. A function definition associates the function name with the function object in the current symbol table. The interpreter recognizes the object pointed to by that name as a user-defined function. Other names can also point to that same function object and can also be used to access the function.
Okay, so that was just a fancy way of saying that you can take this function that we called fib, and you can create a copy of it called f. And just like in above, where they sent a number, the number 2000, into the FIB function, you do the same here. In this case, they didn't put 2000 in, they only put 100, and here's the output. Anyway, enough reading. Let's go on back to the code, and we're going to run the code and take a look at the output. All right? All right. See you there. All right. I went ahead and ran the program without you being around. And now let's take a look at the output. Okay? And the reason I'm skipping that step is because I'm actually putting the displays in the code now so we can see the code that's being executed. All right. So to define a function, the first thing we do is we do the DEF space, then we go the name, and then we make the little bracket things, and we put the name of the variable in there. In this case, it's going to be n. Okay? Now, here we call the function, and we give it the number 2000. Okay? So what does it do with that number 2000? It puts it into the n, and that's what this is for. As it loops through there, first thing it does is it goes like, is a less than n? Well, a is only 0, therefore it's less than 2000. And then it goes, and it does go through, and then finally when it gets to the point where it's above 2000, it breaks the loop. Okay, I want you to see how it actually does that. And then later on here, what we've done is we've taken that fib function and we've made a copy of it into f. And then we do the same thing, only this time we only put 100. And as you can see, it stops after 89, because the next time it would go, oh, 144 is greater than 100, and it stops. Anyway, with that, we're going to end this video, and I'll see you in the next video, Princess. See you then.